So aldehydes and ketones are called carbonyl compounds. And today I'll explain you preparation methods of carbonyl compounds. First preparation method, preparation from alcohols. First preparation method is preparation of aldehydes and ketones, which are called carbonyl compounds also from alcohols. So, if we take primary alcohol, what is the group present in primary alcohol or CH2H group is present, or we take example CH3CH2OH. It is primary alcohol. It is also called two carbons ethanol. When it reacts with oxidizing agent, oxidizing agent means which provides oxygens. Here, two types of oxidizing agents are there: strong oxidizing agent and weak oxidizing agent. But in this case, we use weak oxidizing agent. What are strong oxidizing agents? Potassium dichromate in acidic medium or potassium permanganate in basic medium, which are called strong oxidizing agents. In presence of strong oxidizing agents, first step H2O is separated and we get aldehyde only. And after that, again, oxygens are supplied by very strong oxidizing agents, and the reaction is continued. And carboxylic acid is formed in this reaction. So we select a oxidizing agent that should be weak in nature, so that produces less amount, provides less amount of oxygens. So reaction should be stopped at aldehyde stage only. So what type of compounds are used here? First is pyridinium chromochlorate. What is the role of this? What is pyridinium chromochlorate? Pyridine is a cyclic group with a C5H5N formula. Chromium means chromium oxide is present, plus chloride means HCl. This mixture, what is that? It is called as a pyridinium chromochloride. This produces less amount of oxygens. So reaction stop at aldehyde stage only. Or we use one more compound also, dimethyl sulfoxide, along with oxalyl chloride, that is COCl2 taken twice. This is called oxalyl chloride. So we use this reagent, or we use a pyridinium chromochlorate also. So alcohol, what type of alcohol? Primary alcohol is converted into aldehyde stage only. Their further oxidation is not possible. Okay. So if this alcohol is unsaturated, so we take example CH double bond CH CH2OH. What type of alcohol it is called? Allyl alcohol. What is meaning of allyl alcohol? sp2 carbon and the OH group is attached to sp3 carbon. This sp3 carbon is attached to sp2 carbon. This is called as a allyl alcohol. In case of allyl alcohol, what type of compound is used? Chromium oxide in presence of acid, that is in acidic medium. And also this reaction takes place in presence of non-polar solvent acetone. So this compound mixture, chromium oxide in acidic medium in presence of acetone. So this unsaturated alcohol, what type of alcohol again? Primary alcohol stop at or oxidized and stop at aldehyde stage only. So this is a preparation from carbonyl compounds. So this is a from primary alcohols only aldehydes are prepared. But if we take secondary alcohol, we can use any type of oxidizing agent. What is secondary alcohol? CH3, CHOH, CH3. What type of we use a strong oxidizing agent or weak oxidizing agent? So first step, two hydrogens are separated, H2 is separated out, and what type of compound is formed in this case? What is that? Ketone is formed, and further reaction is not possible at extreme conditions of temperature and pressure only. Second reaction is possible. So this is secondary alcohol when reacts with oxidizing agent, then it is converted into ketone. Second important preparation method is catalytic catalytic dehydrogenation of alcohols. Catalytic dehydrogenation of alcohols. Second preparation method. So here removal of hydrogen from alcohols. Then what is that? Aldehydes or ketones are formed in this reaction. Example, alcohol. This is ethyl alcohol. Ethanol, it is a primary alcohol. When it is heated with copper powder more than 573 Kelvin temperature. So what is the role of this copper? Copper, or we use silver also. This hydrogen is separated and absorbed by copper, or that hydrogen is separated by catalyst. So the compound is CH3 CHO only. So primary alcohol in presence of copper in dehydrogenation reaction, aldehyde is formed. If we take secondary alcohol, once again, secondary alcohol means that OH group is attached to secondary carbon. Secondary carbon means it is attached to two other carbons. Again, in presence of copper more than 573 Kelvin. So what is the compound is formed in this reaction? Ketone is formed in this reaction. If you alkenes are formed, so primary alcohol gives aldehyde, secondary alcohol forms a ketone. And next important preparation is from carboxylic acids. Next preparation method is from carboxylic acids. So we take an example, acetic acid or ethanoic acid, and one more ethanoic. Okay, we take here formic acid or methanoic acid. We take the mixture of ethanoic acid and also methanoic acid. This mixture is heated with manganese oxide more than 573 Kelvin temperature. So what type of reactions takes place in this reaction? From one carboxylic acid, CO2 is separated out, carbon dioxide is separated. From other carboxylic acid, OH, and from first carboxylic acid, H is separated. So which groups are separated here? CO2 is separated, H with OH is separated, that is H2 also separated, and the compound is CH3 CHO is formed in this reaction. So this reaction, what is the compound formed is aldehyde or ketone. What type of structure of that aldehyde or ketone depends on structure of carboxylic acids used in that reaction. Now you use the same method. Try to solve this example. If you take two molecules of CH3COH, then find out what type of compound is formed in this reaction. What is the compound formed in this reaction? Find out. Okay. So in presence of manganese oxide, more than 573 Kelvin temperature, CO2 separated, H with OH is separated, and what type of compound is formed in this reaction? Here, in this reaction, ketone is formed in this reaction. This is a preparation method from carboxylic acids. Next is from salts of carboxylic acids. Preparation methods of aldehydes and ketones from salts of carboxylic acid. So, what is the salts of carboxylic acid? We take example uh, calcium acetate, CH3CO taken twice Ca. This is called calcium acetate, or we can call it as a calcium ethanoate. So, what is structure of this calcium ethanoate? Here, two CO groups are combined with calcium. So we get this compound. What is the structure of this compound is like this. When it is distilled, in distillation process, we maintain some high temperature conditions, and in distillation process, so CaCO3, one stable compound is separated out, and remaining part is CH3COCH3. So in this reaction, ketone is formed. So with the help of this reaction, try to solve this example. What type of compound is formed? Calcium formate. This is called calcium formate or methanoate. In distillation process, when it is heated, find out what type of compound is formed in this reaction. Okay. So again, you draw the structure of this calcium formate. So calcium formate structure OCaHCOOCa. When it is heated and in distillation process, so again CaCO3 separated, and the compound is, what type of compound is formed in this reaction? Here formaldehyde is formed in this reaction, or we can call it as a methanol. So this is called as a distillation process. Here we use a one type of carboxylic acids, or we use two different types of carboxylic acid. Example, CH3COCa, CH3COCa, then reacts with the calcium formate or calcium methanoate. It is called calcium methanoate. Okay, here one more oxygen. Here also one more oxygen. So which group is separated here? From one compound, this CaCO3 is separated. From other compound, this CaCO3 is separated. One compound, this side CaCO3 separated. Other compound, bottom side COOCA CO3 completed. And you add these two groups. So what type of compound we get? 2 moles of CH3 CHO is formed in this reaction, along with separation of 2 moles of calcium carbonate. Here 2 moles of calcium carbonate is separated. So based on structure of two different carboxylic acids, we get what type of compound? Acetaldehyde, which is common name, or we can call it as a ethanol. Ethanol is formed in this reaction. Now, try to solve this example. So here we take 2 moles of calcium ethanoate or calcium acetate. So find out what type of compound is formed in this reaction in distillation process. What type of compound is formed? Try to solve this example. So here again, So from one compound, this CaCO3 is separated. Other compound, this CaCO3 is separated. We get 2 moles of acetone, first compound, and the second CH3COCH3. We get 2 moles of acetone is formed in this reaction. Next is cyclic ketones. So how to prepare cyclic ketones? Here we take the cyclic carboxylic acids. We get this type of carboxylic acid. Then in distillation process, where it is heated, so this CaCO3 is separated. And what type of compound is formed? We get a cyclic compound. This is a cyclic ketone is formed in this reaction. It is called cyclopropanone also. Cyclopropanone is formed in this reaction. The next preparation method, that is from alkynes. So acidic medium, alkynes, next preparation from alkynes. Alkynes reacts with water in mercuric salts in acidic medium. So in this case, aldehydes or ketones are formed. So based on structure of this alkyne, any compound is formed, that may be aldehyde or ketone is formed in this reaction. We take an example, CH3C triple bond CH. This reaction is according to Markovnikov rule. What is Markovnikov rule? Negative part of this reagent attached to carbon with tertiary carbon or secondary, or carbon with a less number of hydrogens, or secondary carbon or tertiary carbon. Positive part is attached to primary carbon. Here it is the secondary carbon and it is the primary carbon. So electrons are transferred to secondary carbon. Always a stable carbocation is formed in this reaction. Tertiary carbocation is more stable compared to secondary. Secondary is more stable compared to tertiary. Sorry, tertiary is more stable compared to secondary carbon. So OH group is added to middle of this carbon. H is added to corner carbon, and the compound formed is CH3CHOH double bond CH2 is formed in this reaction. So this is called as the enol part of that group. Enol, this is the enol compound, and from this enol compound, so this hydrogen is statomerized, means it is transferred to unsaturated carbon. This hydrogen is transferred to unsaturated carbon, and the compound formed is ketone. So formation of ketone or aldehyde, that depends on structure of alkyne. Next, hydroboration. Hydroboration method. Next method. So we take one example, alkyne. This is ethyl. When reacts with BH3, BH3 is a half B2H6, also called BH3, or we take it as a half mole of B2H6 in presence of tetrahydrofuran. So this BH3, it is dissociated into, BH3 is dissociated into H minus, sorry, H plus and BH2 minus, because boron is more negative. So in this case, this H is added to one carbon and BH2 is added to other carbon. So we get this compound. So how many moles of this compound is used in this reaction. We take that further step also possible. Further step also possible. So, how many moles of alkyne involved in reaction with BH, BH3? 3 moles. So, we get this compound. BH2 is added to one carbon, 3 hydrogens are added to other carbon. So, we get this compound, that is CH3, CH, what is that, taken thrice with a B, we get this compound. So, 3 hydrogens are added to one carbon. So B is added to other carbon, and when it is hydrolyzed in presence of hydrogen peroxide, and what type of compound we get? 3 moles of CH3CHO along with what type of compound is formed in this reaction? H3BO3 is formed in this reaction. So this is called as a hydroboration reaction. And next method is ozonolysis reaction. So ozonolysis reaction also two types: reductive ozonolysis and oxidative ozonolysis. In oxidative ozonolysis, carboxylic acids are formed. In reductive ozonolysis, aldehydes or ketones are formed from unsaturated compounds. We take example ethene molecule. When reacts with the ozone, one unstable ozonide is formed in this reaction. It reacts with zinc in presence of water. This above oxygen combined with water and separated as H2O2. This part is separated out. So two molecules of CH2O is formed, or nothing but it is the two molecules of formaldehyde is formed in this reaction. So what type of compound is formed? That depends on structure of that alkene. That alkene may be what is that? Alkene contains two carbons or three or any number. We get aldehydes or ketones in this uh, ozonolysis reaction. One more example. We take this alkene when involved in a reaction with ozone. Here we take this alkene. So find out what type of compound is formed in this reaction. Where unsaturation is present, there ozone is involved. So what is that? We get this compound here, oxygen, with how many hydrogens are present here? 2 hydrogens. So this side, this where the double bond is present, there ozone is involved in reaction. In reductive ozonolysis with zinc and H2O, this H2O part, generally removes this oxygen. Then the bond is cleaved middle of these two oxygens. So what type of compound is formed here? CH3CO, CH3 plus HCHO is formed in this reaction. Propanone and also formaldehyde is formed in this ozonolysis reaction. Next is one name reaction. This is called as a Walker's process. This is a preparation of aldehydes or ketones from alkenes. We take examples CH3, CH double bond, CH2. This is the propene. Propene when reacts with a palladium chloride in presence of water and in presence of cuprous chloride salt. So this oxygen, palladium is separated. 2 HCl, H2O combined with this 2 HCl is also separated. And this oxygen combined with this hydrogen, and this hydrogen is transferred to this side. So we get this compound. In this case, one oxygen is added from H2O group to alkene group. So this hydrogen is transferred to this side. And what type of a compound is formed in this reaction? That is ketone. So aldehydes or ketones are prepared and that again depends on the structure of alkene. So this process is called Vatus process. Again, palladium reacts with cupric chloride. Again, palladium chloride is regenerated. So the reaction is continued. And next method is the what is that hydrolysis of geminal dihalides. Geminal dihalides can form aldehydes or ketones. So we know what is meaning of geminal dihalide. What is the geminal dihalide? If two halogens are attached to same carbon, that is called geminal dihalide. If two halogens are attached to adjacent carbons, that is called as a vicinal dihalide. So here we use a geminal dihalide. What is geminal dihalide? Okay, if it is the two halogens are present at corner carbon, this is a geminal dihalide. And one more condition is two halogens are attached to middle carbon only. Both are example for geminal dihalides. Once again, geminal dihalide means two halogens are attached to same carbon in presence of aqueous base. So once again here AQ indicates the base in presence of water. So what is the role of aqueous base? Aqueous base that two halogens are displaced by OH group in presence of aqueous base. So what type of compound formed here? CH3CH, OH and OH. So that this compound is formed in this reaction. So what is the compound here? Two OH groups are attached to one carbon, but on same carbon, if two OH groups are present, it is not stable. It is stabilized by separation of water. So we get aldehyde in this reaction. Again, aldehydes are ketones formed in this reaction based on structure of that geminal dihalide. If the corner group, corner carbon, if two halogens are present, then always aldehyde is formed. In any of the middle carbon, if two halogens are present, always ketones are formed in this reaction. So here two H groups are attached to same carbon, and what is that? It is when heated, this OH and H is separated. So what type of compound is formed in this reaction? So here we get ketone. Ketone is formed in this reaction. So aldehyde is formed or ketone is formed in any of this reaction, depends on structure. So this is the preparation method from geminal dihalides. Next named reaction is Rosenmund's reduction. Only aldehydes are prepared by this method. So here from acyl halide, oil halides. So COX is present, oil halide. Here chlorine is present, it is called oil chloride. Two carbons are present, so we write here It plus N plus oil chloride, or we can write it as a ethanoil chloride. The compound is ethanoil chloride. This is the IUPAC name, and the common name is acyl chloride. So IUPAC name is ethanoil chloride. Two carbons are present, that is with a CO group, that is called acyl group, or we can call it as ethanoil chloride. When it reacts with palladium and barium sulfate mixture, here sulfur acts as a catalytic poison. So this palladium produces hydrogens, but not excess, less amount only. Here, how many hydrogens are produced by palladium metal? Without catalytic poison, sulfur, excess amount of hydrogens are produced by palladium, because nickel, platinum, palladium can release excess of hydrogens when heated. But when we use this sulfur as a catalytic poison, or in presence of barium sulfate, only few hydrogens are released, and what type of compound is formed here? CH3CHO with HCl. So reactions stop at aldehyde stage only. So this is a Rosenmund's reduction method. So Rosenmund's reduction method is used to prepare only aldehydes, not ketones. Next preparation method is, if you take ethanol chloride, this is ethanol chloride. When it is treated with very strong reducing agent, lithium aluminum hydride. What is the role of lithium aluminum hydride? It reduces all compounds, almost all compounds except double bond or triple bond. Here, each lithium can generate four hydrogens, which is highly reactive and very strong reducing agent. So, in this reaction, we get two molecules of CH3CHO with 2HCl. So, this oil halide is converted into aldehyde in presence of lithium aluminum hydride. So, lithium aluminum hydride also used in this preparation method. And one more preparation method is from hydrogen nitriles. We take example hydrogen cyanide when reacts with Grignard reagent in hydrogen cyanide. So these electrons are transferred to nitrogen because nitrogen is more electronegative compared to carbon. So we know that in Grignard reagent, this group is negative, this group is positive. So the compound is CH plus double bond N minus. So CH3 group is attached to this carbon, MgBr is attached to nitrogen, and the compound is HC CH3 double bond N MgBr. So this unstable compound is formed in this reaction. Again, it reacts with excess amount of water molecules, that is H plus, OH minus, and again, what is that excess amount of water molecules are used in this reaction. So, what is the compound formed is CH3, CHO. One oxygen is added to this group. When oxygen is added to this group, we get CH3, CH4. So one oxygen here added, and nitrogen is attached with three hydrogens. So ammonia is formed in this reaction. MgBr is attached with one OH group. So MgBr OH is formed in this reaction. So hydrogen cyanide always gives acetaldehyde. So what type of compound form depends on nature of cyanides. So here, if you take methyl cyanide or ethane nitrile, find out what type of compound is formed in this reaction. This is ethane nitrile when reacts with Grignard reagent. Try to solve this example. So what is the compound is formed? Here hydrogen cyanide is always forms a acetaldehyde. Now try to solve this example. Here again, so these electrons are transferred to this side. The compound is CH3C plus double bond N minus. So this CH3 group with negative charge, it is with a positive charge. So this is added to this carbon, this is added to nitrogen. So what type of compound is formed here? CH3C, CH3 double bond N NGBr. Again, it reacts with 2 moles of water molecules. Here, this part is converted into ketone. So what is the compound formed here? CH3, COCH3, along with ammonia and NGBr, OH is formed in this reaction. So this is from cyanides and reacts with Grignard reagent. And the next property is next preparation method, ethanol chloride when reacts with Grignard reagent. Generally, in ethanol chloride, that pi electron is transferred to oxygen. So CH3CO minus plus Cl. This is minus, this is plus. So this minus group is added to carbon. This plus group of NGBr is added to oxygen. And the compound is CH3C OMGBr with the Cl CH3. We get this compound. So here MgBr Cl is separated. And what type of compound is formed in this reaction? Ketone is formed with the MgBr Cl is formed in this reaction. So this is the preparation from ethanol chloride. One preparation. Next is Grignard reagent reacts with the cadmium halides. There are 2 moles of Grignard reagent reacts with cadmium chloride. So this is also an important preparation method. So what type of compound is formed here? CH3 taken twice cadmium. Dimethyl cadmium is formed with 2 moles of NgBr Cl is formed in this reaction. So dimethyl cadmium reacts with the oil halide. That is CH3 taken twice CD reacts with we take example CH3COCl. So what type of here 2 moles it is involved in reaction? We get 2 moles of CH3COCH3 is formed. This part combined. Along with CdCl2 is again regenerated. So in this reaction, Grignard reagent reacts with cadmium chloride. Dimethyl cadmium is formed. Dimethyl cadmium again reacts with 2 moles of ethanol chloride or acyl chloride. So ketone is formed in this reaction. Okay. Next is one more named reaction. Gattermann formaldehyde reaction. Gattermann formaldehyde synthesis method. Here, benzene molecule when reacts with the hydrogen cyanide along with HCl, HCl in presence of HCl, and we use the AlCl3. So this AlCl3 removes this hydrogen along with electrons. What type of electrophile is formed? This is the carbon shows a electrophile nature. So in this reaction, what type of compound is formed? This hydrogen is separated by AlCl3. We get a CH double bond NH. This type of compound is formed. HCl, this type of compound is formed in this reaction because this carbon in presence of AlCl3 becomes the positive group. Again, it is treated with excess of water. So what type of compound is formed in this reaction? We get benzaldehyde. Benzaldehyde along with ammonium chloride is formed in this reaction. So this is the ammonium chloride is formed. This oxygen is added here, and we get a benzaldehyde compound. This is called Gattermann formaldehyde synthesis reaction. This preparation method is called Gattermann formaldehyde synthesis preparation method. This method is used to prepare aromatic compounds. And the next preparation method is what is the Stephen reduction. So one more name reaction is called as the Stephen reduction. So in Stephen reduction, nitriles that may be aliphatic or aromatic. When reacts with tin in presence of HCl. So what is the nature of tin in presence of HCl? Tin stannous chloride with hydrogens are formed. So the compound is CH3, CH double bond, NH is formed because this tin reacts with HCl. Tin reacts with HCl. So what type of compound is formed? SnCl2 and hydrogens are separated. So these hydrogens are added to these carbons and we get this unsaturated amine. So this unsaturated amine is also called imine. So imine is formed in this reaction when it is treated with water. So this part is separated as the CH3CHO along with the two hydrogen combined with the NH group and it forms the ammonia. So this is Stefan's reduction, and in Stefan's reduction, only aldehydes are prepared and the ketones are cannot prepared by this method. Okay, next is from alkyl cyanides when reacts with dibol, dibol in presence of water at minus degree Celsius temperature. What is meaning of dibol? Dibol means dibol means diisobutyl aluminium hydride. It is called dibol. So aluminum is present with the two isobutyl groups are there. One, two, three, four butyl groups. These are the diisobutyl aluminum hydride. This is a dibol. So dibol in presence of water converts esters into carbonyl compounds and also cyanides into carbonyl compounds. So here what type of reaction takes place? So here CH3, C triple bond and here C plus N minus we write. So from aluminum hydride, this hydrogen is added to this carbon, positive carbon, because hydrogen is more negative than aluminum. And this aluminum is with the diisobutyl is attached at what type of nitro group and it is hydrolyzed. Hydrolyzed. The what is the compound formed here? CH3. CHO is formed. This part is added with oxygen of water. Again, ammonia with ALH3 is also formed with excess of water. So generally in dibol reaction, cyanide is converted into aldehyde. In the same way, esters also, we take ester CH3CO OCH3. This is the methyl ethanoate. What type of ester it is? The methyl ethanoate. This is ester. This ester when reacts with the dibol. So what is the compound here? This compound is CH3. CHO is formed in this reaction. Ester also aldehyde group. This part formed in this, and the remaining part is in presence of water that is converted into carboxylic acid. So we get this compound. And next is next reaction is with the chromium oxide when toluene. This is toluene. Three alpha hydrogens are present. Alpha hydrogens are must for this reaction. It reacts with the chromium oxide in presence of what type of compound? CH3OCO CH3. What type of compound it is? Anhydride. We take example anhydride CH3CO taken twice O. So the compound formed in this reaction is CHOCOCH3 OCOCH3. We get this unstable compound. Again, it is treated with the water. So the compound formed is benzaldehyde. Benzaldehyde along with the two molecules of CH3 COH is formed in this reaction. So this is the preparation of aromatic aldehydes. So aromatic aldehydes are prepared by this method. Next is Ittod reaction. Next reaction is one more name reaction. This is called as a Ittod reaction. So this is a Ittod reaction. In this reaction, toluene. This is toluene with alpha hydrogen 3 reacts with chromyl chloride CrO2 Cl2. What type of compound is formed here? This compound is formed in this reaction, one unstable compound, that is CH. Two hydrogens are substituted there, OCr, Cl2. These groups are added. How many groups are added here? Two groups are added. And when this is hydrolyzed, what is the compound formed in this reaction is this CHO group is formed and this part is separated out. So this chromyl chloride reaction with toluene finally gives benzaldehyde. This reaction is also called as a Ittod reaction. So instead of toluene, if you take ethyl benzene, so what type of compound is formed? If you take ethyl benzene, what is ethyl benzene? CH2, CH3. So what type of compound is formed in this Ittod reaction? We get CH2, CHO is formed in this reaction. Next preparation method, tolling. So we write alternate bonds or we write ring also. This is tolling. Toluene when reacts with chlorine in presence of sunlight. So in presence of sunlight, when toluene reacts with chlorine, the reaction is what is that? Free radical substitution reaction. Based on number of chlorines, these hydrogens are substituted by chlorine. That depends on how many chlorines are present. Sometimes three hydrogens also substituted. So here two chlorines and two hydrogens are substituted. Here we take 2 moles of HCl and 2 moles of Cl2. So which is separated here? 2 moles of HCl is separated and two halogens are attached on that alpha carbon. Again, it is treated with aqueous base. What is the role of aqueous base? There are two halogens are substituted by aqueous base. Their OH groups are added. So here H2O is separated out and the compound formed in this reaction is benzaldehyde. So benzaldehyde is formed in this reaction. Next, one more preparation method is Gatterman Koch reaction. Gatterman Koch reaction, not aldehyde synthesis, Gatterman Koch reaction. So in this reaction, benzene is treated with CO in presence of HCl and AlCl3. So this CO group is attached on this benzene ring and Cl is separated by AlCl3 and what is the compound form? CHO along with what is that? CHO along with HCl is formed in this reaction. So benzaldehyde is prepared. Here one hydrogen from benzene combined with CO group and we get CHO. Again HCl is separated in presence of AlCl3. So benzaldehyde is prepared by this method. So this named reaction is called as a Gatterman-Koch preparation of Gatterman-Koch aldehyde synthesis reaction. Now, one more reaction is Friedel-Crafts acylation reaction, or one more method, benzoylation also. Aromatic aldehydes are ketones prepared by this way. So in this reaction, we take a benzene molecule. This is a benzene molecule. When it is treated with CH3COCl, so in presence of AlCl3, we know what is the role of electron deficient AlCl3 removes this chlorine and we get AlCl4 minus along with CH3CO plus. We get this compound and this electrophile is added to benzene ring. So what is the compound formed in this reaction? This compound is acetophenone. Acetophenone is formed in this reaction. So this is a preparation method of ketone which contains both aliphatic and also aromatic groups. Now, use this same mechanism. Try to solve this example. Benzoyl chloride. Use the same mechanism. Try to solve this example. So, what is first step of this reaction? C6H5COCl when reacts with AlCl3, we get C6H5CO plus electrophile along with AlCl4 minus. So here, this is the gene molecule. Here hydrogen. So we take here alternate bonds. Here also hydrogen is present. This pi electrons forms a bond. And the compound is, we get this sigma complex, a positive charge, alternate bonds, and here we get a COCH3, again in presence of AlCl4 minus. This hydrogen separated, these electrons are transferred to this position. And the compound formed is, here the compound formed is, what type of compound formed here? COCH3 with the AlCl3 plus the HCl is formed in this reaction. We get this compound. So benzophenone is formed in this reaction. So benzophenone is formed here. So this is a mechanism also. Middle-class acylation reaction. It is a mechanism also. Next is benzene molecule. How many moles we take? 2 moles of benzene. When reacts with the phosgene. What is phosgene? COCl2. This gas is called as a phosgene. Carbonide chloride. It is also called phosgene. So what is structure of this phosgene? This is the structure of this phosgene. Here, benzophenone is formed in this reaction. So 2 moles of benzene molecule when reacts with the phosgene when it is heated. Here 1 more benzene with alternate bonds and hydrogen. I need to write this. So these 2 HCl's are separated and we get benzophenone compound is formed in this reaction. Here benzophenone is formed with 2 moles of HCl is formed in this reaction. Next, this are the preparation methods and so chemical properties. So chemical properties means this aldehydes or ketones contains what type of compound? Unsaturated compound. So the reactions are first type of reactions are nucleophilic addition reactions. So nucleophilic addition means negative group is added to this positive carbon in first step. That is called as a nucleophilic addition reaction. So nucleophilic addition reactions are one type of reaction. Second type is because of oxygen, it is involved in reduction reactions also. And third type of reaction is it is involved in addition followed by elimination reaction also. And next type of reactions are called as a oxidation type of reactions also. And next, separation of water molecules in middle of the reaction or separation of some groups in middle of the reaction. That type of reactions are called condensation. So it is involved in condensation reactions also. Again, these are very important. Aldol condensation. Here it is again divided into Cannizaro's and Perkins reaction. So this type of reactions are possible with aldehydes or ketones. And first we start with okay. So we'll start this. What is the tall reactions in next class. So once again, the chemical properties are nucleophilic addition because here pi electrons are transferred to oxygen and oxygen shows a negative charge, carbon shows positive charge, and the nucleophile is added in first step of the reaction. Electrophile is added at the second step of the reaction. So nucleophile means any group which contains a negative charge, that is called as a nucleophile. So first step nucleophile is added. So this is called addition reaction because CO group is unsaturated. Reduction reaction, hydrogens are added. Addition followed by elimination. In this reaction, first step addition and what is that? First step is elimination again. Addition is a reaction takes place and oxidation reaction. Generally, aldehydes or ketones involved in oxidation reaction to form what type of compounds that are called as a carboxylic acids. And next type by separation of some molecules like water, the compounds are formed. That type of reactions are called as a condensation reaction. So we'll start this all properties in tomorrow's class. So we'll continue in tomorrow's class.